Hello, everyone. Welcome to the last session before the keynote. This is Alan May. I am a volunteer in this OWASP community. I am moderating the session today. I am working today with Synopsys, where I developed a partner set with a leading SI. Synopsys is a leading application security provider. So during the next 45 minutes, you will be listening to Andreas Falk, who will talk about shift-left security with a security test pyramid. Please submit any questions you have in the Q&A tab, which is on the Hoover platform, not here on the YouTube. I will leave 45 minutes, as I said, to Andreas to talk, and then we will have altogether 10 minutes for the Q&A and the wrap-up. And maybe a short word to introduce Andreas. He has over 20 years of experience in enterprise application development. He's working today as a management consultant for Novatech Consulting in Germany, and his focus is agile development and cloud-native enterprise Java apps using the complete Spring platform. I hope it was a good introduction. Andreas, you can always add a few more details if you wish. And I hand over to you and I go in mute. Thank you.
Okay, thank you very much for the introduction. So I share my screen. You can see it. So welcome to my presentation on shift-left security with the security test pyramid. So I make it short. So already introduced myself. So I'm from Germany. I just have to add that I'm also a member of the Open Web Application Security Project. So I always support that for several years now. I'm also a member of the OpenID Foundation because I'm also doing lots of stuff for identity, access management. So my company, that's the only slide of my company, just we are IT consultancy doing different things, and we provide some consultancy special for security like threat modeling, IoT security, or OpenID Connect. And now let's dive into our topic of today, the testing pyramid. I think most developers or builders in OWASP nomenclature know the testing pyramid already. So the main idea of the testing pyramid is that it shows what type of tests you should have in your projects and what amount of tests you should write. What about the feedback of the tests? How big is the effort of tests to write? So at the bottom, you see the unit tests. The unit tests builds should be the most tests you build, because this serves as kind of safety net for the developers. So if you do refactorings, build new things, always run the unit tests to see if you broke anything with your new feature or refactoring. And these tests tend to run really fast. You get feedback in milliseconds. On the next level, you have the service tests. That's also sometimes are called integration tests in Spring, for example. These are a bit harder to write. Typically also using database, some other third-party integrations maybe have much slower feedback already, because usually they start a container doing things. And on the top level, you have the UI tests that's written, for example, using Selenium. And these tests are the slowest tests with very slow feedback. And these tests usually are hard to maintain. So if you have written Selenium tests so far, you know that these tests tend to break very often. And so that's why you should not have too many of these tests. Otherwise, it's hard because of that high effort to take. And there's some other alternative, which I like a bit more, the testing pyramid by Gregory and Lisa Crispin. So this is a bit more detailed one. So at the bottom still you have the programmer tests, can be unit tests or component tests. And above that, you have the API service layer tests. Usually, this kind of tests already tests more business rule and function testing. And on the top level, you have the workflow tests. So this tests don't need to be UI tests. So it can also be some kind of workflow tests that have a bigger workflow implemented, just calling different REST API calls, for example. So it does not have to be Selenium tests. But still, it is a bigger workflow with some business facing thing to test, and typically also runs a bit longer. On the top level, you have the manual testing and also explorative testing. But now, what about security? So in all these testing pyramid, you never read about any security testing here. So if the developer asks themselves, so what to do about security, then typically the number one thing the developer sees is the OWASP top 10 lists. The latest one is from last year, with broken access control now number one. So before it has been injection at number one place. That changed. I showed that OWASP top 10 here, especially because I'm really glad that they also added a completely new topic here to the list, which is called insecure design. And that is completely into the main focus that I'm currently talking about. So it deals about how to find security requirements and how to make sure that you test for all the security stuff. So it starts with use threat modeling for all the critical parts of your application, then integrate the security language and all the controls into your user stories you are writing in your sprints or Kanban processes. Then very important, write unit and integration tests to validate all the flows that you identified using threat modeling or in your user stories. And then also compile use cases or misuse cases. So don't only write business-facing user stories, but also try to write misuse cases for each business use case from the view of an attacker. So what typically does an attacker want to achieve with your business-facing use case? So the most critical thing, if you think about security testing, is you cannot really write good security tests if you don't have any clue about the security requirements. So the first thing to do is find concrete security requirements. And in my experience, this is a really big, serious problem in typical projects because very often managers go to their developers and tell the developers, so the project you are building, the application you are building should be secure. Sometimes they also tell, so it should be secure according to the OWASP top 10 lists. So they also see the OWASP top 10 list as some kind of certification for the application, which it is typically not. Just to have a checklist to check for these kind of requirements. But that does not help the developers pretty much. Additionally, you won't tell the developers so that application has to be fast and has fast response times. So every developer then asks back, what does that mean? A fast response time, 10 milliseconds, 1 second, 2 seconds. And for security requirements, you need that as well. You need concrete security requirements. And two helpful tools are here to help you to find concrete security requirements. The number one thing is also from the OWASP, the application security verification standard. So you get a PDF document with a whole catalog of typical security requirements. And you also can get an Excel sheet where you can then just check what is applicable for your project and then you have a complete list of typical security requirements that you can directly put into your backlog, into your Jira issue tracker, and something like that. And additionally, you also conduct threat modeling sessions to identify flaws and really critical security points in your application, in your architecture. And with these two helpful things, you then identify all the security requirements. To help for testing these security requirements, to evolve tests out of these requirements, then there's another helpful guide called the Web Security Testing Guide by the OWASP that is also used by professional penetration testers to conduct penetration tests. This is full of ideas how to build tests, how to create tests, like, for example, testing SQL injections and stuff like that. And then you can use the OWASP top 10 list just to make sure that you covered all the important aspects of the most critical security issues that can happen. Just to have some security check at the end if your security tests cover all the important aspects. So for threat modeling, we can just talk about that in 1 hour. Threat modeling is always asking for questions. So what are we working on? For that, you typically draw a data flow diagram like the one you see on the slide for login service, for example. Here you have all the data flows with the protocols, with the different components. You have a user that calls a login service via HTTP protocol. The login service uses a user database using GDBC as a protocol. And then you have different trust boundaries where you have changes of user trusts. Like, for example, the login service might run in some cloud provided service, and the user database might work into some data center you own. So there are different trust boundaries defined here. And then you just check what can go wrong in that picture. So one thing that could go wrong here is that you are using unsecured HTTP connection, for example. So somebody could just grab your password from the connection. That could be one thing that could go wrong. And then you are thinking about what are we going to do about it. So in that case, just change to HTTPS connection. And at the end, you always do some kind of retrospective. Did we do a good enough job? And then if you have done all these things regarding security requirements, then you can go further to find security tests that are fitting these requirements. And now we will dive into the different layers of the security testing pyramid so that I can show you ideas how to really start testing security already on the unit testing level. Here you clearly have already tests like the static application security testing. You also test for dependencies so that your Spring Hibernate dependencies do not have any known vulnerabilities. Also, if you're using container images or Kubernetes, then you also conduct a container image scan at that stage. And then you typically add unit and component tests in an automatic execution fashion. And here, typical tests you can already put as a unit test are testing input validation. You can test for broken authentication stuff. You can also do the typical unit testing stuff like trying to bypass business logic that you have defined, write some negative tests that try to break your business logic to do malicious stuff. Then also write tests that check errors and logging messages. So if these messages are not returning sensitive data in the log messages, or the errors do not return complete stack traces, for example, you can also easily test that in your unit tests already. And also an important thing is to test for secure architecture. I will also show that a bit later. So the number one thing that I see in most projects that is already been performed is the static application security testing. Here you have your source code. Then you run that source code with some tool that checks the source code against some rule set. And there are different tools available like SonarQube, Spotbugs, especially for Java. SemGrep is some tool that can cover lots of different programming languages. And at the end, you get a report reporting flaws and also security issues in your source code. The next step would be the dependency check or the software composition analysis, as is also called sometimes. Here you have the software bill of materials as an input, that the SBOM. Then you run your SCA tool that then checks vulnerability databases like the official ones by the NIST, and then also create some reports on vulnerabilities it found in your third-party dependencies. And there are several good tools that have that already built in, like NPM. You can just call NPM audit to see the issues. It is now also directly built into IntelliJ in the latest version with the packager plugin that uses, for example, check marks behind the scenes to do that for you. So you get automatic information in your Gradle or Maven build files for dependency problems. And you can also use the OWASP dependency check. Then the next thing I also want to stress a bit is testing secure architecture and design. This is a very important thing, and you can easily do that with using a tool called ArcUnit. So typically this tool is intended to prove your architecture so that you don't have any violations in your architecture patterns. So for example, if you implement a layered architecture, then it just checks if the calls are according the rules. So no calls from the from the persistence layer to the UI layer, for example. Then you can also test for other aspects, like for security relevant aspects. You can check if your password policies are correctly implemented, if you have the input validation in place, and also for broken authorization, and also important for invalid calls to persistence APIs. So that is also quite helpful to avoid SQL injections. I will show that in a demo just in some minutes. And then one typical thing I also want to show in the demo is how to make sure, for example, to have a password policy in place in your application. So the application security verification standard also has clear rules how to build a secure password security policy, so that the user does not register itself by using a password that only has 5 characters and only uses numbers, for example. As you can see in the picture, such a password is quite insecure and it's cracked instantly. In Java, for example, you could use a framework for that called Passai, which I have in the demos, that can create password policies that can then also be checked using bean validation, for example. So it's time for some demo. Here is also the link for the corresponding GitHub repository I have provided with all the demos. I will only show a part of that demos available here for time reasons. Just go there and also try to look yourself and try to execute some of the demos. What I built here is actually a sample application that administers bookmarks similar to the web browsers are doing that. You have a API for administrating users, and you also have a API to administer bookmarks, just a standard REST API that are provided here as a demo application. And to start things up, I already have run some code analysis over my demo application. And as you can see, it's identified some security hotspots with SonarQube, so it failed already with the quality gate here. I built lots of security problems into the application by intention. So in that case, it identified some of these built-in issues already. So I built in some SQL injection problems in the application that have been identified by SonarQube in the static analysis already. I also used disabled CSRF protection in Spring Security that is also reported here. I have also some others. So I also use some weak hashing algorithm as well. So these are the kind of things that are identified already at that stage. Then I also have spot bugs. So you get similar reportings here, also the MD5, also some SQL injection problems, so quite similar. And I also can show how SAMPREP reports that. So here you can see a sample of SAMPREP that I have run just before the start of the session. Here you see also other stuff. So it does not only check the Java source code. In that case, it has lots of rules for other types of files. For example, it also checks YAML files, bash files, Python files here that are included. Like, for example, it checks for API keys and passwords that are hard-coded here. But it also checks for privileged containers that are not used correctly, like using the root user, for example. And it also checks for, let me show, also again for the MD5 problem here, and it also reports the CSRF problem down here somewhere, and also the SQL injection problem. So these tools report similar things. So I would advise that you at least use one of these tools in your project, and maybe from time to time just recheck with some additional tool just to make sure that this other tool may find also different things. Then the next thing I want to show in the demo are the architecture tests that you can use for the security-facing testing. Here you see a typical architecture test with ArcUnit. This is a predefined rule. So here, for example, I want to test if my application fulfills all the rules that are used for a layered architecture. So in the layered architecture, you typically have a presentation layer where you have the REST API. Then you have a business logic layer here called services, because I use Spring services. And then you have a data access layer here called the persistence layer. And then you define the packages where these layers are located. And then you can just add checks. So that's, for example, the controllers layer, so the presentation layer, is not allowed to be accessed directly by any other layer, but the REST API layer can access the service layer, and the service layer can access the persistence layer, but not the other way around. So this is made sure by these tests, which can try to run that test. So as it is a unit test that should run quite fast, so we can see that the test is green. So all the dependencies are respected in that case. But now you can also try these things for using it for security related stuff. Like for example, for checking if you implemented the authorization on, for example, the authorization on the method layer in Spring. So I use Spring Boot all over the way here in my project. And in Spring, you typically have a annotation for that called the pre-authorized annotation that you just put on every operation, and then here declare what the authorization should look like, if it's a role-based authorization or some dynamic facing authorization. You can do both with that pre-authorized annotation. And here in that case, we just check any methods that are public that reside in that package, in the service package, because we are on the method level to check the authorization. A different thing would be the web UI, the REST API level. That would be checked later in the integration tests. And they have simple names that end with service at the end, and are declared in classes that are annotated with the service annotation of Spring. And then each and every method should be annotated with the pre-authorized annotation, or the whole class should be annotated with that thing. And we can also check if that is fulfilled by our application. And in that case, the test fails because, let me just slow down a bit. So we don't have any authorization checks at all in place because I built that in an insecure way. So it clearly identifies that we really need some kind of authorization checks for all these operations. And you can easily just have that in the unit test layer already. A different demo that I can show is that you can easily test if the developers are using invalid calls for data access. So in that case, it is a Spring Boot application that also uses a Spring Data JPA. So it uses JPA, the Java Persistence API, for accessing data. And in that case, it is not allowed to directly use the Java SQL packages. It is also not allowed to use the org Hibernate packages directly, and also not the JavaX persistence directly, because we use Spring Data, and it can only use packages of org Spring Framework data. In that case, I have implemented two rules. So the first rule is that the service layer should not call any data access layer at all. So it's not intended to call the data access layer directly from service classes. So it's only intended to have the data access layer clearly at the data package. So that's why also here that package is not allowed. And here from the data access layer, only these packages are allowed. So let me also try to run that test here. So it also violates both of these tests. So you can see that's the bookmark service. I have implemented here a bookmark search method that directly has a call to JavaX Persistence Entity Manager, which tends to be some really strange thing. So if I just open up that source code, then you see that we use the Entity Manager here directly, which is an anti-pattern when you're using Spring Data JPA, so you should never have to directly call the Entity Manager. And here you find the really nasty source code by directly using low-level JDBC API. and then just concatenating the input directly with the SQL statement, which is a good reason to have a SQL injection. And you clearly can find that already on unit test level with the ARC unit tests. On unit test level, you can also have tests for password security requirements tests, like here, for example. Here I also just have taken chapters from the ASVS document of the OWASP with the security requirements, and then also implement the test for each and every subsection of that paragraph. Like, for example, that passwords are at least 12 characters in length. And also that you can also use passwords that are 64 characters or even longer. What else do we have? So also a typical thing that no password truncation is performed behind the scenes, which is also quite bad for the user experience. Let me check if we have some results here. As you can see here, it violates something, so it is not checked that passwords are at least 12 characters in length. So we have no violation that was expected here. So we expected one violation of the bean validation constraints, but we have 0, so that's an error here. And we can test that for different kinds of password policy aspects. So you can basically implement most of the subsections of that ASV section here. So some sections are difficult to test, like, for example, here, verify users can change their password. So usually you can only test that in the integration test by just calling some method that changes the password and then checks for authorization here. So these have been the typical things you can do on the unit testing level. On the security service testing level, you can test for additional things like input validation again, but here you can also already test that on the REST API level, for example. Then you can also test authentication parts, authorization parts on the REST API on the web layer as well. You can also test for session management, especially if you have implemented the session management by yourself, which I would not recommend. I always recommend using a session management provided by your framework, like Spring Security, or from the application server side. Yeah, for example, if you use WebLogic still, or from JBoss Wildfly, then use the session management provided from that framework. You can also test for file uploads, test that only defined types of files are accepted when uploading. And with that, I mean that's not only you check the extension of a file, but you also check, for example, the magic bytes, so that a user cannot upload an executable file, for example, instead of a PDF. You can then also add tests for injections, and also test for security misconfiguration, like the typical misconfiguration that you might have for cross-origin resource security that you configure for your browser security precautions. You can also make big mistakes by putting, for example, wildcards in your origin here. So one thing I also want to stress here is that the general access control design is an example from the ASVS, which I can also show in the demo just shortly. So then let's jump directly to the demo again. So we had the unit testing and the architecture level. If we look at the integration testing level, I just want to show how to test for SQL injections as an example here. So for testing SQL injections, you can just start with some easy payload that you find everywhere. If you just have a simple Google search for testing SQL injections, you typically will find a payload just like that one. So with that payload, you just add that payload to your where statement at the end of the SQL statement. And with that, you can easily check your own service calls or data access calls if you have some problems regarding SQL injections. With that payload, I just called my search bookmarks method where I built in such a problem by intention. I just put in that SQL injection payload. And usually, if you do not have any SQL injection problem, you would expect that you get an empty result when testing the search operation by putting that payload inside, because I did not have defined any bookmark that would match that search criteria. But let's see what this test will tell us. So this is an integration test, so you will recognize that it runs a bit slower, but I just have run that before sometimes, so that's why now it runs really faster. And as you can see here, we did not get back an empty list, but instead, so it was expecting empty, but instead, because we have a SQL injection problem here, we just have been returned the complete contents of the table that is built in an H2 in-memory database in that case. So this is a clear sign that we have a SQL injection problem here, and you can easily just add tests to test that for all your service calls in that case. So I have also put in some other security problems as well in different locations here. This is just one example that you can test. So this was about the service layer. And on the top layer, you can then have your dynamic application security testing stuff. Like, for example, the OWASP tool. There's also commercial variant of that by Stackhawk. Then you have the Portswick Burp Suite. That is the commercial thing compared to the OWASP tool. Then you have also specialized tool. You can just use the SQL map tool for finding SQL injections, the Nmap tool to find open ports on your environments, and yeah, check what services are running there. But you can as well use just standard tools like the Gatling tool that is usually used for performing stress testing, yes, some load testing stuff. And with that, you can also easily just test locally already if your application has problems according to denial of service attacks. So just put in some stress testing with the Gatling tool, put lots of loads on your REST API and see if you can improve things regarding denial of service attacks. Like, for example, adding an API gateway with some resilience patterns like rate limiting stuff, for example. Regarding the test tools, so these typically run in that way that you have a running client, like a single page application, then you have a running server with a Spring Boot backend, for example, and then you put that test tool just in the middle of these two sites as some kind of proxy. And this proxy then gets all the requests and responses from the client to the server and the responses back from the server. It can record all the request responses, and then you can run a scanner, automated scanner with some predefined rule set that can conduct passive or active scanning. Passive scanning is just checks that are conducted when executing the requests and responses by just looking at request responses for some unusual patterns. And the active scanner just tries to attack the application using the well-known URLs you have identified, and just trying to put sequence injection attacks, cross-site scripting attacks, and all the stuff that you know about from the OWASP top 10. For the OWASP tool, this is quite convenient to also include that in your CI/CD pipeline with the container that are provided. Here you have a baseline scan just doing passive scanning. The most important one for my REST API would be the API scan. Here you can just put open API definition to OWASP with all the URLs that you have defined. And with that, you can easily just test against that defined APIs. You can also conduct a full scan, but a full scan I would advise not to put in your regular CI/CD pipeline, because a full scan might run for hours depending on your size of the application. So just put that one in some nightly scan and put the baseline scan or API scan as part of your usual CI/CD pipeline. I can also show you some only short demo here. I've set up the application already. So the application is running here, as you can see. No, this is the wrong one. This is the application. So I cleared the logs already. And I can now start the SAP API scan. I have also a script already inside the project. So I just start that because it takes some time to show the results. I already have run that before. Here you can see the results that OWASP has found in an automatic fashion. So it detected some server errors that it detected with 500 HTTP status. The really critical ones are, again, sequence injections. It detected some application error disclosure with some stack trace it detected. Also some cross-site scripting with persistent cross-site scripting maybe, and also reflected cross-site scripting as well. So with cross-site scripting, you would not fix that primarily on the backend. You would fix that in your single-page application by using some good framework like Angular that has context-aware encoding already in place, and also sanitization in place. It is really difficult to solve cross-site scripting on the backend. The only thing you can do here is also put input validation. So the last thing I would just to show is, because the time is already quite up, is that all the things I have shown to you so far, you should automate completely. So automate the static code analysis, automate the dependency check as part of your CI/CD pipeline, and then also do a container image scan with Privy, for example, as an open source tool if you're using containers, and also Kubernetes, stuff like that. Then you put the image into the registry, then you deploy that to a Kubernetes cluster, and then you have the running application. And then you can conduct dynamic security scan using OWASP, for example, as shown. And on the top, you have the manual testing. Here you can also conduct security-related manual testing, like explorative security tests. You should do security code reviews. So this is a really critical point. You always should have security code reviews in place as part of your project. So in our projects, no code will be pushed to the master branch in our Git version control without any security code review. So it always requires at least one human person to conduct a security code review. And then clearly you also have the pen tests. So with explorative security tests, you just try to test some special functionality, like, for example, you want to test some special business functionality in your application for injection attacks. For that, there's also a quite useful tool called Bug Magnet, which you can install in your Chrome browser, for example. And then you have a context-aware menu available on each and every input field, where you can just try out different payloads and try to find nasty things. Then one anti-pattern I still find in lots of projects, unfortunately, is that lots of projects only rely on penetration testing and don't conduct any continuously performed security tests at all. So they follow the DevOps approach already. They do continuous delivery, deploy several times a day, for example, but only do penetration tests maybe 2 times a year. So that's a typical pattern I often see at companies. And on the top, you see the work that an attacker is doing. So attacker typically work 24/7. They don't know holidays. They don't know nothing about project vacations and stuff like that, or weekends. So they try to hammer on your application all the time. And if you only have penetration tests like 2 times a year, all the deployments that are running after such penetration tests will be a blind spot completely. So you can never be sure if you are safe from attacking. So that's why continuously testing for yourself is so important. As a summary, you should put security testing on each and every layer of your security testing pyramid, as shown in demos and also on the slides. And a second summary is that it is not sufficient to only have tooling in place and conduct automated testing, but it is really important to understand each other very good. So developers should also show empathy for operations and also for security and vice versa. So a main idea, for example, would be that a developer just tries to work one day at the security role. The security person works for one day as a developer and also operations. With that way, you can much more improve the understanding for the other side, which are typical problems you have to care about. And this is a really critical point to understand each other. So DevOps is basically a thing of cultural things and not just putting tools everywhere. So this is an important thing here. So that's all I wanted to tell. So I'm open for questions now. I just put in the URL of all the demos on the bottom, so you can note that down. You can scan my code for any contact details if you want to contact me. So feel free to ask your questions.
Thanks a lot. This was very clear. I have looked. Can you also look? I did not see any questions. I refreshed it. I hope I have the right link.
So it was so clear that nobody has questions. So that's
so it was very clear, I guess. I have a question for you. Just a moment. I'm rechecking on the Hoover platform. Yeah, we still have 10 minutes left. Yeah, we have. Okay, I come back here to the Zoom. Yeah, we have an audience of 29 attendees plus you and me, that's 31. So I repeat, for the benefit of the audience, please do not hesitate to raise a question in the Q&A, not here on Zoom or YouTube, but on the Hoover platform. We still have another 5 to 10 minutes. In fact, I will raise a short question. I like the last slide where you talked about communication, and you mentioned something which I have never heard before in 20 years of development and security, whereby you said that the developers should spend maybe a day, a year or so with the security folks, and basically the security folks operations and vice versa, right? So this is basically what I call a cultural change, so that people understand that all the three, let's say, functions have different goals and challenges. Now, since you work as a consultant, do people start to implement such a best practice and such a good advice that you listed? Do they start to do that? Is this a big company, let's say, attitude, or rather a small company?
Yeah, it better works at smaller companies, I have to admit. So in bigger companies, you have much more problems, because these companies tend to fulfill all the compliance issues all the time. So in that company, in that companies, you only do security by bureaucracy, so as I tell sometimes. So these people are interested just to check marks, so they can report to their management, oh, we have done our things here, so we have made sure that we looked at each and every component here, but that does not improve anything on security from my mind. So it's much better to really exchange roles sometimes, because I always hear developers, oh, that security folks, they don't want us to deploy anything to production, so they always say no to our new features, and then vice versa. So security people, oh, the developers don't have any clue about security, they always build insecure things, and we should teach them all the time so to not do that, and they don't understand our penetration testing reports at all. And these are the misunderstandings, and you can clearly understand much better if you just take over the role for one day and see that also the security people have their own problems to deal with. So
but have you seen companies experience this, I don't know how you call that, rolling job, whereby they switch, so that they understand? Because today I know that there is this frustration that you just mentioned, if sometimes even the hate, because the developers see the other ones as delaying, the sprints and the timelines. The operations people, of course, see the risk of having regular updates, and the security folks are a bit in between, right? Caught between operations. And basically, we moved from development to DevOps, and now it's DevSecOps, But I mean, do companies? I mean, is it does it need the sponsorship of a CISO, of a CIO, to get this? I don't know how you call that, rolling job cultural updates happen. I mean, I have never heard about that, and actually, this is very interesting that you mentioned this.
I only tried it out so far in a smaller company. In my current project, in big companies, it's almost impossible to do that. So you have so many standards, and
and silos, right?
Guys are so far away from our developers, so they sit in their own apartment, and they are not integrated somehow in our project. So that's the main issue we have. So they always tell us, oh, not to do that one, not to do this one, and that's the biggest issue we have there.
No, that's a very good point. Okay, I'm still looking. We still have 5-6 minutes left. Just for the benefit of the audience, this was the last session. We have 5 sessions parallel, and we will soon have the final session, which is a keynote, 15 years of OWASP, top 10. Has the cloud made a difference? Which, of course, is a very interesting topic for all of us. Let me quickly check if some more questions have come up. I refresh.
I just wanted to mention as well, so I don't like the term DevSecOps pretty much. Because I see security is always have to be in DevOps already. So for me, the security thing should be a silent thing, so you should not have to stress DevSecOps. So
Yeah, so that's security is built in
Yes.
in the development cycle, tools, culture. Yeah,
Yeah.
yeah, that's a good point. I'm sure
Because
you will
I
make
always
that.
have problems to put it to SecDevOps, to DevSecOps, or DevOpsSec. So that's the number one problems I already have. So. And also
Yeah,
by
I'm
meaning
sure.
shift left, there's also some confusion sometimes. So by shift left, I don't mean basically you just have to shift left everything, but you should rather put security in all your project phases. So put it
Yeah, yeah.
anywhere.
At Synopsys we say shift everywhere because security
Yeah.
should be, from the beginning to the end.
Yeah, exactly.
And it's more a cultural habit and yeah, not just a process.
And also don't forget your applications that are not in active development anymore. So that's also a problem lots of companies forget about. So that even those applications need some security fixes from time to time.
Yeah, you are talking about then like more legacy applications.
Yes, exactly.
Or application that are subject to less updates. Yeah.
Yeah.
Okay. Yeah. Okay. Well, any maybe final advice or tips from your excellent presentation?
Let's just start with some easy tests, like putting tests for sequence injection, or at least for the authorization. So as we have seen, broken authorization is the #1 issue on the OWASP top 10 list. So you clearly should put lots of effort, make sure that you don't have any holes in your authorization matrix.
Okay.
And with Spring Security and frameworks like that, they have so excellent testing support built in already, so you can easily write that kind of automated tests.
Okay. Well, thanks a lot, Andreas, and thanks a lot to the audience for making it on the Thursday afternoon here. It's close to 5 p.m.